Right, everyone, I've decided to do a data structure in C. I'll do I'll do a stack. This stack's going to be in C, but kind of modeling a little bit like how it would be if it was a class, but obviously in C you don't really have classes. So let's just start by sharing the screen and let's get started. So let's first start with a header file. Do a pragma once. There's a header file. I'm gonna make a new type called stack. So we'll start with type def. I'm gonna call it a stack. Now inside this type, I want to get the elements. Also the element size. I'm going to want its general logical length. And its allocated length. I also want to take in a free function because it's going to be like a void star, so it's going to want some sort of function to free it and leave it open. Okay, that'll do for the data structure. So what I've done is I've got elements. These are pointed to some elements. It's tracking the size of each element, the length, the current length, and then the logical length of it, and then the allocated length of it, what's been allocated. Then we're going to take in a free function. So what I want this to be able to do is I want it to be able to kind of instantiate. So we can't actually just make classes in C. So I've decided if we do this, we can add some functionality to it and group them together. So if I said stack new, and I want it to take in a stack pointer, I want it to take in an element size, and I want it to take in a free function. Okay. I also want to be able to dispose of the stack after it's finished. I can say a stack pointer. I want to be able to push and I want to be able to pop. So and let's pop. So pop's going to be literally the same sort of thing. Then I want to be able to make the stack grow at times, depending upon how big it gets. So okay. So we've got a few sort of functions. The new and dispose can static and the push and pop. So this is like just a header file. So these are what the function is going to look like. So I'm going to utilize those when I'm sort of making the C file. So this. I want to include stack.h. I'm also going to include a few other things like stdio to give me like printf and stuff like that. I'll probably want standard lib as well to be able to do a few bits of malloc and other things. I'll probably want standard int as well to be able to do some little operations on the ints and stuff. I'm definitely going to want string because I'm going to be utilizing some of the manipulation stuff there. So that should be enough headers. Now I'm going to paste all the bits here. We've got some of these going to be created. And they're not returning anything. So it's fairly straightforward. Let's see. So the new is going to be like the actual new for an actual class, but we don't have classes in C, so we need to just use like memory manipulation and do stuff. I want to assert that the LM side is above 0, because if it's not, we can't really build what we want. So let's do that first. Otherwise it'll stop what it's doing. So now if I take the S, LM size, set it equal to LM size. Then I want to take the S logical length and set it to 0. Then we'll set the allocated length to 0 as well. So it's just like making a new object, if you like. Then what I'm going to do is set up the LMs. I'll start with like 8 elements to start with, and then we can grow it and do whatever. We're going to do a malloc call to dynamically get the stuff, and I'll do 8 times LM size. So it can hold up to 8 elements. Now we're going to assert that that worked and it's allocated the memory. So S LMs is not equal to null. Otherwise it'll let me know about that basically. So that's kind of like an operator new on a class. Next, I think we can try the delete or dispose. We're just going to have the ability to dispose of a stack. So first, let's check if the free function is not null. Which means we've set a function to free it. Then we're going to loop over all the logical length and literally run the free function on each element. So for I equals 0, or I is less than the stack's logical length, then we'll do an I++ increment. So I started with this sort of way of doing things, so I'll do that. Okay, so now all I'm going to do is I'm going to run the S's, the stacks. Okay, stacks free function. Do it using car star for now, just so it's got a size. We're just coercing it to be that. Plus I times size. Okay. So that will run the free function. Once it's run the free function on all the elements, we can then free the actual single element, or the pointer to the elements. So that allows it to be a generic one. So these are pointers. So this LMs is just a bunch of pointers to a pointer, or a pointer to pointers. So it's kind of, you have to free all of the elements first, then you can free the pointer to the elements afterwards, which in essence becomes the object's pointer. So really the start of the elements is the this, for instance, or whatever you call it. Okay. So next I'd want to be able to push. So let's do that. So I want to check that the logical length, basically, let's check if it's full, as in, you know, it's not, it's reached the end of itself. So if it is, then we need it to grow, basically. So if the logical length is equal to the allocated length, then we're going to want it to grow. So just S grow on. Okay. Now let's set up a target. We're going to coerce it to be a car star for counting ability. Yeah. Right. So we're going to coerce it into being a car star first, so that we can actually use it to kind of count and do the length and stuff. So we've got to do that plus the logical length. Multiplied by the LM size. Sorry. Right, so we've set our target. Now what we want to do is a mem copy of target to the element from the element address with the element size. So let's do a mcpy target LAM address. LM size. So I'm going to be taking the SLM size in it. So okay. That does that mem copy. That's pretty much it, really. I don't really know, it's not. I want to also increment the logical length, don't I? So S logical length plus. Okay, so that's a push. It's pushing onto the stack. Now I'm going to do a pop. Let's do that. It's kind of semi-reverse of it. So we're going to decrement the logical length first. So S arrow minus minus. Then I'm going to set up the source, which is virtually the same thing as the well, it's literally exactly the same in this sense. It's this, but it's called source. Well, I'm calling it source. Be specific. And then I'll mem copy the opposite way around. So now this time I want to copy to the element address. And this time it's from the source. And it's of size LM size. Okay. Now, growing is just literally going to be making the allocated length bigger. So what I'm actually going to do for allocated length is I'm just going to literally use a doubling strategy and do times equals 2. So I'm just going to multiply it by 2. It's just going to double every time. So that should be fine. Now we're going to reallocate. So S LMs equals realloc. Realloc. And we're going to say S LMs. We're going to want the size to be the allocated length multiplied by the element size. So S allocated length multiplied by S element size. Okay, so that's basically a the equivalent in C of a stack class. So we've got new, we've got dispose, which would be like delete. We've got push, we've got pop, and we've got grow. And it's utilizing this struct, this type that we've created here. And this is about as close as we're going to get to a class, but in C. Save this. And I think that'll do for now. Time's getting on, I'm going to have to get stepping soon. So I hope you enjoyed the difference, or something different, I suppose. It's still data structures. It's a little bit off the stuff what we're actually doing as such, but the concepts are the same, and it kind of shows the idea of kind of the early days idea of how we're moving on to object orientation. So thanks for watching. Bye-bye.